Hi, everyone. Thanks for having me here. I'm Tina Huang. I'm the co-founder and CTO of Transposit, where we build an API composition platform. I've been working with APIs almost my entire career. I started out at Apple Computer working on system-level APIs, building early AppKit framework for OS X. And then later on, I moved to Google, where I built API-driven applications. And then at Twitter, where I worked on platform services, dealing with APIs both internally and externally facing. But I honestly didn't cheat and get notes from Bill ahead of time. But as much as I love APIs, I'd like to start this conversation by talking about, hold on. Sorry, everyone. I've lost my slides. I'll just use the clicker here. So I'd like to start this conversation not by talking directly about APIs, but about the power of automation. It should come as no surprise to everyone in this room that businesses are constantly looking for ways to improve their efficiency through automation. That's because manual tasks are terrible. Not only is it really, really time-consuming to do each of these individual tasks, but they end up incurring tons of different overhead. You have tickets to track what tasks need to be done. You need workflows to manage all the different handoffs between various tasks. You have project managers whose primary job is to track the inevitable delays that you'll have at each one of these handoffs. And on top of that, manual workflows are super prone to human error. It's really easy, the moment humans are involved, to mistype a name or click a wrong button. So we often look to computers to automate this work for us. We're currently living in this golden age of SaaS. Companies are adopting more and more SaaS applications, which has been a total boon to business productivity because it means we have all these specialized applications to manage various parts of our business. But this also creates lots of silos. With each application, we end up with yet another data silo. And so that means that tasks that we used to be able to do all in one place are now split between lots of different applications. And what's worse is at the junctures of all of these applications almost always mean manual workflows. Some person taking data from one application and manually inputting it into another. So with this increase of SaaS, we start to see a corresponding increase in the demands for automation. Luckily, application providers are starting to realize that all of their applications need to be platforms, and that they need to empower the users of their platforms by giving them APIs. APIs give you the power to automate. APIs allow you to programmatically call an application, allowing you to turn all of those manual workflows into automated ones. Unfortunately, the majority of the current automation tooling out there is focused on that which can be fully automated. That is, tasks with a concrete trigger that can be fully completed without any sort of human involvement. This kind of automation is super appealing because of its simplicity. Since there's no human interaction, you don't need to worry about building interfaces. But it really limits what you're able to automate. There's a large array of tasks that require just that little bit of human subjectivity or guidance. Customization on this kind of automation can also end up being really challenging. And that's because you're effectively, through all of this configuration, programming the rule set for all the different paths that the workflow might take. And as much as we like to think that we can anticipate every way that this path could go, we end up missing steps. and hitting edge cases. And so this kind of workflow automation is also very fragile. So how can we get the efficiencies of workflow automation into more and more of our workflows? Well, fortunately, there's something called human-in-the-loop automation. Human-in-the-loop automation is automation, but at each step along the way, we give humans the ability to interact and influence its direction. So let's take a common use case. Oftentimes, when a new user signs up for your product, you want to create a corresponding record in some sort of marketing system. And quite often, you want to annotate that record with its referrer information. Unfortunately, this referrer information often comes from a variety of different sources. It might come from a Google spreadsheet that someone created to track all the attendees at events like the one today. Or it might come from a system like Google Analytics. The problem is, records across these different systems are often inexact matches. So when we have a fully automated workflow here, we often end up with inaccurate data and a very messy data cleansing problem to deal with later on. So a better way to think about it is, why not let the machines do the hard part of gathering together rough matches across all of these systems, possibly with some sort of AI to best detect the matches, and then presenting it to a human where they have a streamlined process to select the best matches before continuing on with the workflow. Now we have the best of both worlds. Humans can do the part where they can add the most value, and machines can do the rest. But with human-in-the-loop automation, we introduce a few new challenges. One of them I already alluded to before. Now that we have interactivity, we also now need to build user interfaces. And almost everyone knows designing UIs is both challenging, but also really time-consuming to build. But even worse than that, we don't want to find ourselves accidentally exacerbating this problem of having too many application interfaces in this massive ecosystem by creating yet another application interface to deal with. What we really want to do is bring the interactivity to whatever system of engagement people are already participating in. And so that might mean integrating into Slack if you're talking about DevOps or engineering tooling, or integrating into Zendesk if you're talking about support. Another problem is, how do you manage all of the different identities of who's interacting with the workflow? It's much better to have an individual authenticate who they are in each one of the underlying systems rather than relying on shared API keys. We can automate a whole lot more if we can give each individual access to everything that they can do in each one of these underlying systems, rather than having to build automation for the lowest common denominator for everyone who has access to that workflow. With human-in-the-loop automation, rather than thinking about it as man versus machine, it's really about allowing humans to do where they can add the most value, and then automating out the tedious parts. So now that we have some understanding of what human-in-the-loop automation is and why we want it and some of the challenges, I'd like to walk through a few common patterns I see this automation take. The first one is very simple. Let the human be the trigger. I like to call this the free pizza button. So imagine you're a customer support person at a pizza delivery place. Oftentimes, when you have a customer complaint, the easiest thing to do is give them a free pizza. Unfortunately, this can end up being a little bit time-consuming for the support rep. They might need to file a ticket to track the customer complaint, create a new coupon code, gather customer information, pull it all together. But if we were to fully automate this case and have some automated system for complaining and giving out free pizzas, people are pretty clever, and they usually figure this out. And suddenly, free pizzas for everyone. So in the ideal world, we let the customer service rep do what they do best, which is let them determine who deserves a free pizza, and then give them a one-click button to automate out the rest of that process. The second pattern I'd like to talk about is what I call the human detective. That is, we let the system notify a person that a problem has occurred. And then we provide tooling to help that person investigate the situation and determine the best course of action. And then make it easy for them to actually take action on those findings. So let's take a second and talk about developer builds. We all know that developer builds can be flaky. They can fail for a number of transient reasons, like bad network connectivity. But if we just were to automatically rebuild on every failure, it would be pretty inefficient. So instead, let's consider a human-in-the-loop automation where we notify the developer that a build has failed. But let's not just stop there. Let's give them tooling to help them search through build or deploy logs, and then give them access to quick actionability to either retry the build or revert the change. Now we've taken what previously involved 5 or 6 different systems and pulled it all into a single place. And the final pattern is approvals. Approvals are needed for a couple different reasons. Sometimes it's just you want a human for accountability. But sometimes it's because machines aren't perfect. At Transposit, we use Google Hire as our applicant tracking system. Google Hire gives us this one-click button to email a candidate where it automatically pulls the candidate's name and information out of their resume. This has unfortunately led to some pretty embarrassing circumstances where I've emailed candidates where the name has been in all caps. Having that final approval process, or what I like to think of sometimes as that human sanity check, it not only gives you accountability, but it also really keeps us from making a lot of embarrassing mistakes. What we're really talking about here is building applications that enable business automation. There's a class of problems where these trigger and event-based workflow automation can solve the problem, but for everything else, we need to build applications. Applications give us the interfaces that allow us to bring humans into the loop at those critical junctures. And what makes this class of applications unique is that what they're really about is integrating and combining together different applications through APIs. Our job as developers is increasingly about building applications to enable more and more of these workflows. And building these applications is increasingly about connecting and combining together APIs. But unfortunately, this rarely looks like those nice, easy-to-plug Lego blocks from the previous slide. APIs unlock a ton of possibilities, but they can be a real pain to work with. Who here has spent more time than they care to admit to digging through some nitty-gritty API documentation just to get the thing to work? That's because APIs often reflect how the service owner thinks about their data or how their data infrastructure is laid out, rather than how you, as a consumer of those APIs, wants to use it. One example of this is how they've chosen to cache or index that data often dictates what APIs are even available to you. One manifestation of this is a problem that's often referred to as the N+1 problem. That's when you have what really feels like it should be a single API request to get a list of items, ends up being N+1 requests, where for each one of those items, you're doing a follow-up request to get more details and then merging them all together. Another example of this problem is pagination. We often talk about pagination like it's one mechanism, but in practice, pagination is lots of different mechanisms. One of the most incredible examples of this is the Slack API. Slack has 5 different pagination mechanisms, all sitting side by side for a single service, all as part of the same API. And who wants to guess how they might solve this problem? That's right, probably a 6 pagination mechanism, one to rule them all. The same lack of standardization also happens with authentication. But luckily here, things are getting a little bit better with OAuth 2. But even with OAuth 2, there's still a lot of variation between implementations, and there's still always going to be a ton of legacy auth out there. And then once you factor in things like rate limits and retries, by the time you get your applications to work with APIs, you often end up with some sort of convoluted mess. But this complexity problem we're talking about here is so much worse than the complexity within a single application. And that's because we're talking about the complexity of interactions between multiple systems that all have to communicate over the network. This means that effectively all application developers in this API ecosystem, they effectively need to know something about distributed systems and security. They need to be able to know how to code against unreliable networks. They need their code to be resilient to long network latencies. They need to know how to write their code in a way such that it throttles API requests to not overwhelm the underlying systems and invoke rate limits. At Transposit, we call this problem of having to write lots of glue code to connect and combine data from all of these systems the problem of API composition. And the reason we spend so much time thinking about this problem is because the number of APIs out there, it just keeps increasing. And the complexity of interactions between those APIs, it grows exponentially the more APIs we use. And on top of the complexities of composing together APIs, there's also the additional challenge that every SaaS application has its own concept of identity. That means when you're trying to build applications that sit across all of them, you need to start thinking about how do you link together all of those identities so that you can properly authenticate all the underlying API calls. So let's take a moment to quickly recap. We know that we need to build applications to integrate together all of these different tools we have out there. And we know that these tools empower us with APIs, giving us access to do all kinds of things. But each one of them, unfortunately, is unique and has its own steep learning curve. So what we ideally like to do is get out of that business of having to encode in excruciating detail all the minute interactions of each API and be able to operate at some sort of higher level. We like to be able to work at an abstraction that allows us to specify the intent of what data we'd like to retrieve and not have to deal with all of the mechanism of how to actually get that data through APIs. At Transposit, we do this using both SQL and a JavaScript API. But for the next few slides, I'm going to focus on SQL because I think it does a great job of exemplifying what I mean by working at this higher level of abstraction. So let's take a very simple select statement. Here, the developer is just asking, give me a list of items from an API. But even in this most simple of examples, we actually can bury away a lot of the mechanism of how to call that API, such as, how do I authenticate? Do I need to worry about reauth when that token expires? What about request signing? What HTTP method do I need to call? What is that parameter a query parameter, a path parameter? What version of that API do I want to use? And then layer on something just a little bit more complicated. Let's say I want to fetch more results. And we've already talked about how pagination is a bunch of different mechanisms. So here, we can abstract away things like, this API happens to use cursor auth. And let me grab the cursor from one request and iteratively call more until I have 100 results. And then there's connecting together multiple APIs. And once again, I'm able to just define this as a simple join. And we're able to deal with the complexities of things like that n+1 problem of having to first fetch the list of items, and then do a follow-up request for each one of those items, and then merge it all back together. Even authentication can be abstracted away. And so here you can see I have two different handles representing two different Google Calendar accounts, one representing my work account and one for my personal account. And once again, the developer only needs to think about what conceptual account I want to talk to, and not think about the mechanics of which is the proper access key or credential to apply in this case. So finally, I'd like to take some time to help show how we've used such a platform in order to automate out a lot more of our tasks. And it was very fortunate that Bill spent his whole time talking about DevOps, because almost all of my examples fall into that category. The first is something that we call, where's my commit? So at Transposit, we have this tiered release process. When a developer commits their code to head, we automatically deploy it to our demo environment. Once a day, we cut a build that goes to staging, and then after a 24-hour bake period, we release it to production. Unfortunately, when I'm wearing my product manager hat, oftentimes all I have is a Jira ticket that I want to know, when can I test this, or when can I expect a customer to see the fix deployed? And so this process used to look like I'd message some engineers on Slack. They would dig up that Jira, grab the Git SHA from the Jira ticket, dig through ECS, tell me when it would be deployed. And so one of my engineers was motivated to write me a Slack/command. And now I can just give it a Jira ID, and it can tell me when I can expect it at each of these environments. At Transposit, we use Circle CI for our continuous build and deployment system. The default Circle CI integration in Slack is super basic. It basically posts status of success and failure to a single Slack channel. So we decided that we wanted to enhance this integration by giving quick actionability whenever a build fails. And so here, we've added 3 different buttons to the build failure notification. One that lets you quickly retrieve the build artifacts from Circle CI to allow that developer to do investigation on why it failed. And then buttons to retry the build or revert the change in GitHub. And like many other engineering teams, we use Slack as the hub of our on-call operations. So when an alert fires in our monitoring system, it posts an alert to our Slack on-call channel. Here, the SRE and engineers on call can chat and collaborate over what's happening. But one common problem is making sure that everyone is discussing the same metrics and incorporating those metrics into the conversation. So before, this would often look like people copying and pasting links, or sometimes if an engineer or SRE was really motivated, they might take a screenshot of an alert and then manually upload it into the Slack channel, into the conversation. And so here too, we've added a Slack/command that will automatically fetch an image from AWS CloudWatch and then post it to the Slack on-call channel for us. And then for a bonus, we've made it easy to then create a JIRA from this Slack conversation. Again, not only are we saving all of this context switching between applications, but we're able to pre-populate this JIRA with important information that engineers often forget to fill out, such as the linkage between this conversation that's happening in Slack and JIRA. And finally, we built this interactive chatbot named after our mascot, Iggy. We use Google's Dialogflow to parse common problems that people have when they're facing and debugging production issues. And so here, I'm asking Iggy Iggs, please show me all of the logs for a particular request. And he kindly responds with answers for me. So to sum it up, let's automate more by abstracting away all of the mess of APIs so that we can build more applications. Once again, I'm Tina Huang from Transposit. You can feel free to sign up and try our product at transposit.com or follow us on Twitter at Transposit. And I think I have 3 minutes left for questions.
Any questions real quick? All right. We can grab Tina during the break then. All right, thank you so much.
Thank you.